Okay, today we're going to continue talking about 7.1, which is Introduction to Hypothesis Testing. Last lesson centered around the basics of a hypothesis test. We talked about the null hypothesis, and we talked about the alternative hypothesis. Okay, the null hypothesis was the statistical hypothesis that contains a statement of equality. So it's represented with H sub O, and it has a statement of equality. So less than or equal to, greater than or equal to, or equal to. The alternative is represented by H sub A, and it has a statement of inequality. So it has less than, greater than, or not equal to. And we just practiced taking information in words and writing the claim as a mathematical statement, and then writing the alternative hypothesis from the null hypothesis or vice versa. So today we're going to continue with our hypothesis testing. And it's pretty much just a notes day today and a couple of example problems. And then we'll continue working very slowly with 7.1 over the next couple of days. Okay. So, no matter which hypothesis represents the claim, because remember, it could either be the null hypothesis or the alternative hypothesis, depending on what's given to you and what kind of sign is given to you, whether it's a statement of equality or inequality. You always have to start your hypothesis test by assuming that the equality condition in the null hypothesis is true. So essentially, we're just going to start off by assuming that the null hypothesis is true. The alternative hypothesis is a proposition that something different is going on. And then at the end of the test, one of two decisions will be made. You will either reject the null hypothesis, or you will fail to reject the null hypothesis. Okay. Now, since we're working with a sample, not a population, it's possible that we make the wrong decision. It is possible the wrong decision gets made. And this is because you're just working with a small number of information pieces or data pieces from an entire population. So if your sample isn't representative of the entire population, it's very possible that you might go through the test, you might make all the what would seem to be correct decisions based on the sample that you've been provided, but in the end, your decision could still be wrong. Okay, and that's just part of the hypothesis testing. That's just the way it goes. All right, so now we can talk about level of significance. If you do make the wrong choice, there are two types of errors that could occur from making the wrong choice. The first one would be a type 1 error, and that occurs when the null hypothesis is rejected. So you go through the process, you think, all right, so this null hypothesis that we have here is not true, I'm going to reject it. But in reality, for the sense of the entire population, it is true. That would be a type 1 error. And then you guessed it, a type 2 error is when the null hypothesis is not rejected, so you're accepting it to be true, but it is actually false for the entire population. So the level of significance is your maximum allowable probability of making a type 1 error. And it's denoted with what looks like a lowercase a, but it's actually the Greek letter alpha. So it's written a little bit differently. Looks very much like a lowercase a, though. The probability of making a type 2 error is denoted with the Greek letter beta, which looks like a curly B. Okay. So after stating the null and alternative hypotheses and specifying the level of significance, a random sample is taken from the population and the sample stats are calculated. So the sample stats would be the mean, the standard deviation, so on and so forth. The statistic that is compared with the parameter in the null hypothesis is called the test statistic. We could use the mean, or any of these other sample stats, which we will see all of the tests for in further sections of the chapter. Okay? All right, so now for a p-value. So in the event that the null hypothesis is true, then a p-value, which is also called a probability value, of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than one determined from the data. And we'll work with p-values a little bit further down the road. It'll start to tie in once we do our other tests throughout Chapter 7. Today, what we're going to focus mostly on in terms of practice is determining the nature of the test. So the type of test to conduct is indicated by the alternative hypothesis. So that's important. It's not determined by the null, it's determined by the alternative hypothesis. Okay, so that means it's determined by the hypothesis that has signs of inequality. So we are going to be basing it off of the less than, the greater than, or the not equal to sign. Okay, the left-tailed test means that the alternative hypothesis contains the less than symbol, okay? The less than symbol. The right-tailed test means that the alternative hypothesis contains the greater than symbol, and the two-tailed test means that the alternative hypothesis contains the not equal to symbol. And then we have the following diagrams that could be rough sketches of each test. Okay, so the left-tailed test, we have the left side or the left tail shaded in for the area of the p-value. The right-tailed, we have the right side. And the two-tailed, we have an equal amount on each tail being shaded in. So for these examples, we're going to state the claim, the null hypothesis, and the alternative hypothesis. Then we are going to determine whether we're using a left-tailed, a right-tailed, or a two-tailed test, and we're going to sketch a normal sampling distribution and shade the area for the p-value. So a school publicizes that the proportion of its students who are involved in at least one extracurricular activity, so the proportion of its students is 58%. So it's exactly equal to 58%. So P equals 0.58. Since this is a statement of equality, this would be the null hypothesis. Okay, the alternative hypothesis would be not equal to. So since we have not equal to, it means we have a two-tailed test. And we would just sketch out our normal curve, our two tails, shade in our two tails. And that would be our two-tailed test. Next one, we have a car dealership announces that the mean time for an oil change is less than 12. So the mean is less than 12. So in order to write our claim, we would write mu is less than 12. Okay, mean is less than 12. So that doesn't have a statement of equality in it. So that one would actually be our alternative hypothesis, which means our null hypothesis would be mu is greater than or equal to 12. So in this one, since we have our alternative is mu is less than 12, that's going to be a left-tailed test. And we can draw our normal curve, and we shade in the left tail. And then last but not least, number 3, a company advertises that the mean life of its furnaces is more than 12 years. So we have mu greater than, 20, not 12. That would be our alternative hypothesis because there is no statement of equality. It's just inequality. Our null hypothesis would be less than or equal to 20. Since this is greater than, we have a right-tailed test. Okay? All right, so there we have it, tails of the tests. What I want you guys to do is try these 3 problems. This is what you will be posting for your work today. Make sure you state the claim, state the null hypothesis and the alternative hypothesis, determine which test is being drawn, and then just sketch in a diagram of the sampling distribution for the test that you choose. Okay, just scan that in as a PDF, post that, and you are done for today. Let me know if you guys have any questions.